Python. A very simple program that we're using to print out a table of square roots. You see that inside our function that we've defined, we have a root each to print a square root, and we're calling that function from so that it prints out the square roots of all the numbers between 1 and 2. Right, so let's follow along. We're going to go to Eclipse and write that work.
Okay, so we're in Eclipse now, ready to start our first C program from scratch. We still have our project from last time up here, so first thing I'm going to do is close that project. So I'm going to right-click on Hello here in the Project Explorer and choose Close Project. I think it's a good idea to do that because the more projects you have open here, the more work Eclipse has to do, and that can slow your machine down a little bit. So I'm going to right-click in the Project Explorer again and say New C Project. And then I'm going to choose, again, Hello World ANSI C project. And at the top for project name, I'm going to say Square Root. And then I'll click Finish. All right, so we've got our project. If I open that up, and I can go down and open up Source, and I'm going to double-click on squareroot.c to open that in the editor. And we see that it starts out with a comment. Now, in Python, we started comments with the hash symbol. In C, comments are going to be /* and then */, so I can have multiple line comments here. I'll go ahead and put my name in as the author, and I'm going to get rid of some of the rest of the noise here. We can also write single line comments in C, and those start out with 2 slashes, and I'll be using some of those to sort of annotate our example here. And so we're going to start out with some include statements. And what include statements do is tell us what header files we need to use in our program. And so these are a little bit like the import statements that we'd have in Python. And we're almost always going to use this stdio, that stands for standard IO, which says we want to use IO functions or input-output functions from the library. And for this program, I'm also going to use math. So I'm going to put in math.h here. Later on, we'll see that there are other places we can import header files from. But in this example, the angle brackets say that we're using the standard header files. If you're interested in finding out some more about standard header files, you can do a Google search for standard C headers. I'm sorry, standard C libraries, and read a little bit more about what's available for including there. All right, so the next thing we're going to do is write the main function for the program. And so I've got main already declared for me here. I'm going to clear out the body of that. And we'll just sort of walk through step by step what we need here. So a function declaration in C starts out with a return type. So we didn't need that in Python, but in C and in Java, we have to say what is the type of the thing that we're returning from the function. And a main function is always going to return an int. And this is an error code that's returned to a program that might call your program. We won't do much of that in this class, but you see in some uses, like in operating systems, we'll write C programs that can be called from a command line, and we'll get an error code back that can then be used. Now, we're just going to assume that this program is successful, so I'm going to put in a return 0 at the end. And 0 is the code that means that we were successful. Now, main is the name of the function. And then in parentheses after that, I list my parameters. So for this function, I'm going to just delete that. I'm not going to have any parameters. So main doesn't take any arguments, and it returns 0. And now in the body of main, I'm going to call a helper function to print out my table of square roots. So I'm going to call print root table, and I'm going to pass the argument 10 to it. And so inside the body of main, these are really just like the Python statements that we saw in the Python example. We call the print root table function with the argument of 10, and then we return 0. So I'm going to save that. Let's go ahead and declare print root table and see how that's going to work out. So first I'm going to put in the declaration of this function. So I'm going to say void for the return type. We'll talk about that in a second. And then put in its name. And then I'm going to list the formal parameters. And the parameter I want here is going to be called n. And then I'm going to use curly braces to define where the body of this function is. So we've got a few differences from Python here already. I have the name. Well, that's a similarity. But in C, I have to declare the return type. But print root table isn't actually going to return anything. And so there's a special keyword in C, void, which says I'm not actually going to return a value. And then I've got my declaration of the parameter over here. Well, it's called n. And so that n part at the end, that's like we would have in Python. But in C, I have to declare the type of that parameter also. And so I'm going to say that n is going to contain integers, or type int. And by declaring that type, that allows the C compiler to write a more efficient runtime version of this than we would get in a language like Python. So now if we look at our call down in line 18 and compare it to the function declaration up in line 13, in line 18, we're passing 10 as the actual argument. And in line 13, when this gets run, the parameter n will get the value 10 when we run the body of this function. All right, now inside the function, I want to create a loop that'll go through and print out this table of square roots. And to do that in C, I need a loop index variable. And so I'm going to declare a local variable. So this is a local variable. And the local variable is named I, and it's going to store values of type int. And I could just declare it like that if I'm going to assign to it later. Or if I want, I could actually put an assignment here to initialize it right away to make I equal to 0. And then after that, I can write my loop. And my curly braces around it. And I'm going to actually start at 1. And so a loop in C has 3 key parts. This is quite a bit different than a loop in Python. The first part initializes the loop. And it does that by setting I to the value 1. And now the second part of this loop declaration, that tells us what check we should do at the end of the loop to see whether there's more work to be done. And so this check says, if I is less than or equal to n, do the loop one more time. And then after it does the loop, it checks it again. Is I less than or equal to 1? If so, it does it another time. And then the third part here, this I++, that's called an increment statement. And it's executed at the end of every time through the loop. And so the I++ there says, take whatever value I has now and make I have the next value. So if I was 1, I get to the end of the loop, the I++ runs, and I would change from 1 to 2, and so on, until eventually I becomes greater than n, and then the loop will stop. So what's left to do? Well, I need to write actually the code inside the loop to do the printing. And there's a function in C called printf that will do that for us. And we'll go into some detail on how this works later. But for now, I'm just going to use this format string that says give me a 2-digit decimal number, and then give me 7 characters worth of a floating point number. And I want 3 characters after the decimal point. And then I put a \n that says, hey, after you've printed out those 2 numbers, then I want a new line. Write the next stuff in the line after that. And then in printf, after I give that format string, I can give the variables that I want to go into the spots that I defined. And so I can put an I here to say I want to print out the value of I. And then I can call the square root function, and that's going to be in that math header that we imported above to get the square root of I. And then I finish up my parentheses, and I end the line with a semicolon. So that's another difference from Python. In Python, the statement ends with the end of a line. In C, the statement doesn't end until I get to the semicolon. So I could format this differently. I could put the I and the square root on separate lines, and the end of the print doesn't come until I get to the semicolon. In general, we won't do that, but sometimes it's useful if you have a really long line of code. All right, so that should take care of running my loop from 1 up to and including n, and then printing out the value of I and the value of the square root of I at each of those. So if I've done that right, I should be able to save it, and then come over to the Project Explorer, right-click on square root, and choose Run As Local C++ Application. And it compiled, and if I go down to the console, I can grab this edge above the console and drag that up so I can see more of the code. And I see that I have the square roots of all the numbers from 1 up to 10.
Okay, we hope you enjoyed writing your first program in C. Until next time, I'm Matt.
And I'm Kurt.
All right, see you next time.